All right, so ladies and gentlemen, we're at chapter 4.4. We're finishing up our notes from yesterday. We should know how to do long division. I showed you guys that yesterday on the video. With long division, we're going to need that when we do oblique asymptotes. It's like the last thing we do today, okay? We should know how to find domain. We're going to review that again today. We're going to find, we should know what vertical, horizontal, and oblique asymptotes are. And now today, we're going to find them, okay? We'll also talk a little bit about goal number 4 using transformations, but the nice thing is with goal number 4, you can always type it in your calculator if you're not sure, okay? So let's go ahead and get started from where we were yesterday. I believe we graphed problem 6 and 7. We graphed 1 over x and we graphed 1 over x squared. Is that right, guys? Can you give me a thumbs up if that's what we did? That was a thumbs up. All right. So when we graphed the 1 over x, we had our domain was all reals except for 0 because there's a vertical asymptote at x equals 0. There's also one here at y equals 0, okay? And then we plugged in 1, we got 1, so we graphed 1, 1. We plugged in -1, we got -1, we got this nice pretty part of the graph. Okay, remember, asymptotes, your graph is getting closer and closer to, but never gonna touch it. Never gonna touch it, never gonna touch it, never gonna touch it, never gonna touch it. When I graph 1 over x squared, again, domain, it can't be zeros because there's a vertical asymptote there. And then y equals 0 is a horizontal asymptote, okay? We plugged in 1, we got 1. We plugged in -1, we also got +1. So it's on the second quadrant for this part, okay? And that was an even function. This was odd, symmetric to the origin, and then even. All right, let's do transformation. So when you guys are doing your homework, 4.4, and they'll say like 33 or 35 or what have you, we're using transformation. So look back at your notes and it should help you out here, okay? So when I take a look, I've got g of x equals 1 over x minus 2 plus 1. I want you to go back when we did quadratics. Remember parabolas? We started moving these things around. Right? When we had something like this, we had a parabola and we moved this one to the right, opposite of what you see, and we move this one up. Okay? The exact same is going to happen on this one. X minus 2 is moving to the right, and then this is moving it up. And what moves, the first thing I move is my asymptotes. Okay? So basically, it's going to look like this graph, but my asymptotes are moving. Okay? That's the idea. So normally I have a vertical asymptote at 2. The +1 doesn't change it. I don't know what I just said. The vertical asymptote is normally at 0. The +1 just leaves it alone, but it's the -2 that moves it 2 units to the right. If I think about domain, the denominator can't be 0. So set x minus 2 equal to 0, add the 2 over x cannot be +2. And that's because at 2, 1, 2, there is a vertical asymptote. Okay, so there's a vertical asymptote now at 2. Same value of your domain. And when I have the 1, normally I have a horizontal asymptote at 1, or at 0, excuse me. The shift left to right doesn't move it at all. It's the shift up or down that's going to move that horizontal asymptote. So this vertical shift moves my asymptote up to y equals 1. Okay, so I have a new vertical asymptote at x equals 2 and a new horizontal asymptote at y equals 1. Any questions on the two asymptotes, y'all? All right, all right. So you can plot some points if you want. You don't have to. I'm choosing 3 and I'm choosing 1 because my vertical asymptote is at 2. So I'm going to graph a point on the left and a point on the right. So the next integer after 2 is 3 or 1. I'm going to plug those in. Okay, you can do this in your head probably. Plug in 3. 3 minus 2 is 1. 1 over 1 is 1. Plus the 1 on the outside is 2. So from the origin, I'm going to count over 1, 2, 3, and up 1, 2. And now that part of the graph gets closer to these asymptotes and never going to touch. Same idea with this one. Plug in 1. 1 minus 2 is negative 1. 1 over negative 1 is negative 1. And then plus 1 is 0. So I get, from the origin, I got over 1, up or down 0. So it's just 1, 0 right there. And again, your graph is getting closer and closer to these asymptotes, never gonna touch them. Okay. Nice thing is, quiz or test, you're freaking out and you're not sure, you can always throw it in your calculator. So if I go to my calculator, let me clear out this stuff that I got. I'm just gonna type it in like I see it. When I see parentheses, though, I usually put in, or excuse me, when I see like a binomial, I usually put in parentheses. So I'm gonna do 1 divided by parentheses, x minus 2, close it, and then plus 1. So I got 1 over x minus 2 and then plus 1, and I'm going to graph this guy in zoom 6. And now I have a pretty good idea what that thing looks like. Okay. If I want to verify my asymptote at 2, I'm going to go second trace value 2. Okay. So we get x is 2, and I get no y value, and that's because there's an asymptote right there. Let me know if you're not getting this graph. And then I can plug in 3. If I plug in 3, I got 2. If I want to plug in 1, I got 0. So now I have a few points that I can graph on this thing and have a pretty good idea of what values are going on here. Okay. Anybody not getting this graph or having issues with the graph? Again, anytime I'm typing in binomials and trinomials into a fraction like this, I always use parentheses. Okay. You guys have any questions? All right. Nobody's asking questions. I don't see anything in the chat, so I'm going to move on. So when I look at number 9, I wouldn't worry too much about 9. I'm going to talk about it, but again, would I worry too much about this on a quiz or test? The answer is no. I would definitely know how to do something like this, though. Okay. And again, number 8, I could throw it in my calculator and have a pretty good idea what it looks like. Okay. So when I look at number 9, the first thing I notice is the domain can't be 0. Okay, my denominator can't be 0. X squared can't be 0. And if I square root it, it still can't be 0. So I know I've got that vertical asymptote. No, other than that, transformational wise, I really don't know anything else going on here. And the way they have it set up, I could simplify this and make it look more like this one. Okay, and the way to do that is just go ahead and reduce everything so that it's x squared over x squared and negative 2 over x squared. So it looks more like transformational form, like this. Okay. So x squared over x squared is 1, and then minus 2 over x squared. Now I still don't really know just the way it's written, so I'm going to flippy flop, and then hopefully it makes very clear on what this 1 is doing. Okay. This 1 is like this vertical shift with the parabola. This is a shift up 1 unit. Okay, so that's going to move my horizontal asymptote. Normally, it's at 0, and now it's going to go up 1 unit. So now my horizontal asymptote is at y equals 1. Okay, so far so good. So I have a vertical asymptote at x equals 0. That's just from my domain, right? You can't have 0 as my domain. And now I have a horizontal asymptote at y equals 1. What is going on? Ethan, be quiet. Sorry, guys. He's playing in Teenage Mutant Ninja Turtles over there. It's getting a little crazy. All right, so now the question is, what in the world is this A value? This number on top is the A. Okay, That's like if I had something in front here, this would be the A value. If it's negative for a quadratic, that's a flip. And if it's a number bigger than 1, then it's a stretch vertically, okay? Now, you don't really have to worry too much about that, because if you just plot a couple points, again, on either side of your vertical asymptote, 1 and -1, the A value will be taken care of, okay? So if I plug in 1, you can plug it in here, you can plug it in here, kind of wherever you want, okay? So if I plug in 1 squared right here, 1 squared is 1, -2 over 1 is -2, plus 1 is -1. So when I go over 1, I go down 2. 1, 2, right there. Same thing happens when I plug in -1. -1 squared is 1. -2 over 1 is still -2. -2 plus that 1 is -1. So when I go over 1, down 2, I put it right here. And now these graphs are getting closer and closer to these asymptotes and never going to touch these asymptotes. Okay, looks something like that. All right, so this one had a few things going on. First off, the way it was written, you can always break it down into transformational form. So this is transformational form right here. Okay, we had a vertical shift, and then we have an A value that's negative. Ethan, you're gonna have to go away from me. It's too loud. I'm talking right now. So sorry, bud, but you have to get away from me. I'm teaching right now. Do you guys have any questions with that, y'all? Again, the nice thing is I could throw these in the Calc. I have a pretty good idea what they visualize, okay? So this is the good stuff. This is the last thing. This is the big stuff. So if you guys are sitting there watching Netflix, I would stop what you're doing and write this stuff down. Here you go. This is the good stuff. This is what we're doing in the next few days as well. When we start graphing vertical, horizontal, and oblique asymptotes, you want to know how to do this. So this is, you're actually going to see this multiple days in a row, okay? So when I'm looking for vertical asymptotes, it's similar to domain. So we're going to find our domain first, okay? And what you'll notice is the domain and vertical asymptotes are related. However, if you want to find vertical asymptotes, we're going to put the fraction in lowest terms, okay? And then whatever's left in the bottom, whatever's a factor of the denominator, is going to be your vertical asymptote. So the first thing we need to do is we're going to find the domain of this fraction, right? So let's find the domain of this one. Factor. First rule of factoring, we can take out that GCF. And then how do you factor x squared minus 1, y'all? Lorelei, Lisa, Madeline, Duncan, Hayden, Chris, Madeline, what do you guys say? How do you factor x squared minus 1? How do you factor that guy? X squared minus 1, y'all. Shout it out. Perfect. X minus 1, x plus 1. Fantastic. Now my domain is found in this, right? So now we find our domain. Domain is a set of all real numbers such that x cannot be what makes each one of these x's 0. Okay, so set each one of these guys equal to 0 and solve. You would get 0, can't be 0 for this guy. +1 and -1, opposite of what you see in parentheses. So I can't have 0, plus or minus 1. There are 3 restrictions there. Okay, so again, I got domain is the set of all real numbers except x can't be 0, plus or minus 1. Okay, now the next part, the new part is I want to find my vertical asymptote. Vertical asymptotes are from your reduced fraction. This fraction doesn't reduce at all. So if it doesn't reduce, then your vertical asymptotes, your verts or VAs for short, whatever you want to say, your vertical asymptotes are the same values that you have here. So you're going to have a vertical asymptote, one of those dotted lines that your graph is getting closer and closer to. It's going to be at 0, and x equals 1, and negative 1 or plus or minus 1. So you're going to have 3 vertical asymptotes. Okay. And if you wanted to look at this graph now to give you guys a visual, just real quick, I've got 3 divided by parentheses. I got x raised to the third. You don't have to graph it. You can just look at what my graph looks like. Minus x using parentheses around binomials and trinomials. I'm in Zoom 6. I graph it. Okay. And I can definitely tell I've got an asymptote right here at -1. I can tell there's one at this x-axis, and then I can see there's one right here at 1. So I've got a whole bunch of vertical asymptotes going on with this graph. Okay. And eventually we're going to start graphing these in the next section. So we need to know how to do this. All right, any questions on my vertical asymptotes? So the next one, I look to factor. I can't factor this guy, right? This denominator, domain, denominator. I try using the square root method. We saw this yesterday. I subtract 1. I get x squared can't be -1. And I square root it. What's the square of -1, y'all? What do you guys get when you square root -1?
1.
No, good guess though.
Non-real answer.
Yeah, it's imaginary. You get plus or minus I. Okay, so on Valentine's Day, if you didn't know, write your Valentine's Day, square root -1, heart you. Yeah? I love you. Ha ha ha. It's I when you do a square root of a negative. All right, so what does that mean in the real world? Your domain is all real numbers. There is no restriction in your domain. There's no numbers that you can't plug in. And anytime you have a domain of all real numbers, your VAs, your vertical asymptotes, your verts for short, there is none. So if there's no restriction in your domain, there can't be any vertical asymptotes. Questions, y'all? All right. Last but not least, I've got x minus 3 over x squared plus x minus 12. When I'm trying to find my domain, the first thing I gotta do is look at my denominator and try to factor that. Okay, so I'm gonna look here. I'm gonna try to factor. And you guys tell me, what are factors of -12 that add up to 1? What are factors of -12 that add up to 1? Shout them out. Maybe I froze there. What are factors of -12 that add up to 1, y'all? Zach, you got them? Sydney, McKelvey, Jess, Ryan, what are factors of -12 that add up to 1?
-3 and +4.
Boom. Okay. Now, domain is found in the denominator, right? So we look for that domain. I'm going to write the domain up here so we have enough room. Domain is the set of all real numbers such that x cannot be the opposite of what I see in parentheses. So that would be positive 3 and negative 4. So 3 and negative 4, the opposite of what I see. That way, if I plug in 3, 3 minus 3 is 0. 0 on the bottom, undefined. Okay, same thing with negative 4. Okay, so far so good. Now, this is the trick here. This is where people think their vertical asymptotes are 3 and negative 4. That's not right. If you're finding vertical asymptotes, you want it in lowest terms. You need to reduce if you can. Okay, so if you're looking for vertical asymptotes, you must reduce. In this case, I reduce, and the x minus 3's cancel. Now, a lot of times I'll have kids say that, oh, this is x plus 4. And I go, where is the x plus 4? And y'all would say it's on the bottom, right? So it should be 1 over x plus 4. Okay, so this thing reduces, and now I have 1 over x plus 4. This is where you find your vertical asymptotes. Whatever's left. So whatever's left, x plus 4, I have a vertical asymptote at the opposite of that, negative 4. So that's my vertical asymptote. Okay. Any questions on finding vertical asymptotes? So my question to you is, what's going on this graph at 3? So this is where I throw this in the calc. I'm going to plug in the original equation here. I'm going to plug in parentheses x minus 3, close it, divided by parentheses x squared plus x minus, above the addition sign, 12. Okay, so I've got parentheses x minus 3, close it, divided by parentheses x squared plus x minus 12. If you have a binomial or trinomial, put parentheses around the whole thing, or you're only dividing by the first term, and you don't want to do that. You want to divide by the whole thing. So I'm in Zoom 6, Zoom Standard. Remember our domain, there's something going on at 3, and there's something going on at negative 4. Okay? So when I look at negative 4, it's very clear to me that I have an asymptote here. I can't see it unless I have a TI-83. The TI-83 guys will actually show this line, okay? And they use the kind of like an Etch-a-Sketch. You guys remember those red things where you move the little dials around and move it around? They use the connect the dot kind of idea, like an Etch-a-Sketch. They'll connect the dots, so they'll graph this and go, oh my gosh, there's a point way up here. So they go way up there, and they connect this dot here. So there's a big line. Just know if you have a TI-83, that is really not part of your graph. Some older 84s do that too, but they've kind of changed how they graph. All right. So at negative 4, if I go second trace value, negative 4, I shouldn't get anything. It's a restriction in my domain. There's an asymptote there. But when I look at 3, I can definitely tell there is no asymptote type of graph going on. Okay? So when I go second trace value 3, there's still a big old nothing right there. So my question to you is, what do you think is going on right there? Any ideas? There's not an asymptote. What do you think's there? Any ideas? Can you see it? If I go to 2.9999, I got something. And if I go 3.000001, I see something. But at whatever 3 comma whatever, there's nothing there. And basically what's there, if you don't know, is like a big old open dot. All right, and we've seen that in piecewise functions in chapter 2.4. We saw some graphs that had big old open dots on there. Okay, so basically what's there? There's a hole in your graph, dear McKelvey. Dear McKelvey, there's a hole in your graph, dear Gavin. There's a hole. You guys have a big old hole in your graph, and we want to find it. Okay, well, how do we find it? Well, I know where the hole's at. I know the hole's at 3 comma something because it's part of my domain. And all I have to do is plug it in. If I plug it in, I got 3 plus 4 on the bottom is 1 over 7. 1/7 is about 1.142-ish. Okay, so 1/7 is where the hole is. Eventually, we're going to start talking about calculus in this class, and the end of May or beginning of May, end of April, we'll start talking about limits. And basically, we want to be able to find the limit of this graph. And eventually, we'll talk about this as a removable discontinuity, which sounds really fancy, but basically just means there's a big hole in the graph. Okay? So I always say if you reduce it, you remove it, and that's a hole. Just like if you're outside, if you dig a hole, you're removing dirt. So if you reduce it, you remove it. If you remove dirt, it creates a big old hole. Okay? Now, kind of cool thing is if I graph this other function that's reduced, okay? If I graph that, if you just watch this, I got 1 divided by parentheses x plus 4, okay? The blue one I already have graphed. The red one is tracing the exact same graph. Except when I go second graph and I look at the table, at 3 on the blue one, there's an error. But on the red one, that hole has been filled in because it's been removed. Okay? So this one has a hole. This one, the red one, does not. It's been removed. Okay? The graphs are identical. They have asymptotes in the exact same spot. The original one has the hole. The other one does not have the hole, and I can find it then. Okay? So hopefully that makes sense on how to find vertical asymptotes, and gave you a little extra for that, which is finding the hole. All right, do you guys have any questions with that, y'all? I know that was pretty deep. Haha, get it? Deep hole. Haha. Oh, man. All right, bad joke. I got more dad jokes, though, if you want them. All right, if you guys take a look, last thing. Horizontal and oblique asymptotes. Horizontal and oblique asymptotes. If I want to find that, and again, I hope you're taking notes, guys. These are just some rules that we have to follow to find those horizontal and oblique asymptotes. First thing we got to identify is n is the degree on top. Remember, degree is the largest number. So that is your numerator's degree. Okay. M is the degree, largest exponent on bottom in your denominator. We're going to compare the degree on top and the degree on the bottom to see if it has a horizontal or oblique asymptote. If the degree on top is less than the degree on the bottom, if n is less than m, just the rule says we have a horizontal asymptote, and that's at y equals 0. If the degree on top is equal to the degree on the bottom, n is equal to m, then we're going to have a horizontal asymptote, and that's going to be at y equals a over b. Now, everybody freaks out. They go, what is a over b? A over b is just your leading coefficients on top. Okay, it's basically just cover up every single thing then, and then whatever's the first two numbers on top and bottom, that's your horizontal asymptote. So I'll explain that here in a sec. So that's this a over b thing. Okay? If n is equal to m plus 1, the degree on top is equal to the degree on the bottom plus 1, then we have an oblique asymptote. And we find that oblique asymptote using long division. Okay, so you're going to get a line. You're going to get y equals mx plus b here. And to do that long division, we did that on the warm-up yesterday. Last but not least, the degree on top is way greater than the degree on the bottom, so greater than n plus 1, then there is neither horizontal or oblique, so there's none. Okay? So this seems super scary, but if we can just follow our rules, it's not that bad. All right, so let's zoom out here so we get the rules on as we're looking. Okay? All right, so we look at the degree on top and the degree on the bottom. So I'm highlighting My degree on top. My degree on top is 2. The largest exponent on top is 2, and the largest exponent, m, is 3. I compare them. Is n less than m? Is 2 less than 3? You betcha. N is less than m. 2 is less than 3. Then I just read what it says. I have a horizontal, and that's at y equals 0. And then I'm done. I don't have to do anything. Okay? All I have to do is follow the rule. Know what n is and know what m is, and then look at the rules. Okay? I look at the next one. I look at my exponents, the degree on top and the degree on the bottom, the largest exponents. The degree on top is a 2. The degree on the bottom is a 2. I compare them. Is n less than m? Is 2 less than 2? That's silly. Is 2 equal to 2? You betcha. N is equal to m. 2 is equal to 2. Then it says I have a horizontal at y equals a over b. I have a horizontal y equals a over b. Okay? A over b is just basically cover everything up, and the first 2 numbers in front is what I got left. So just cover everything up, and it's these first 2 numbers. That's a, and that's b. So I end up with y equals 2/3 is my horizontal asymptote. Questions on those 2 rules? Last but not least, I look at the degree on top and I look at the degree on the bottom. So I highlight them so you guys can see them. So that degree on top is a 2, and that guy, if I don't see a number, that degree is a 1. I compare them. Is n less than m? Is 2 less than 1? No, that's silly. Is n equal to m? Is 2 equal to 1? No. Is 2 equal to 1 plus 1? Yes. N is equal to m plus 1. 2 is equal to 1 plus 1. So then I know that I have a oblique asymptote, and I have to use long division. So I do long division. And you're like, oh man, long division, but it's super fast. You only do it for about a step and a quarter here. Okay? So you look at x. You say, what times x gives me x squared? And y'all would say, what? What times x gives me x squared? Somebody's giving me the x symbol. Okay, x. X times x is x squared. X times -2 is -2x. Draw my line, change both signs. Positives turn to negatives, negatives turn to positives. So that's now negative. That's now a positive. This guy cancels. 4x plus 2x is 6x. Now you do it one more time. You say up here, what times x gives us 6x? You want to bring this one down, you can. You don't have to. What up here times x gives me 6x? And y'all would say what, 6? Stop. You don't have to go any further unless you want to. Okay? All you care about is y equals mx plus b. I've got mx plus b. I've got my y equals x plus 6. I am done. That is it.